Welcome to the first session of From Inference to Intervention on the operative logics of machine learning by Magdalena Krysztoforska. Magdalena is currently a fellow at the IC Berlin and a visiting researcher and member of the Responsible Computing Group at the Max Planck Institute for Security and Privacy. Her research focuses on machine learning systems and their sociopolitical consequences, drawing on perspectives from critical AI studies, philosophy of science, and generic epistemology. In recent decades, machine learning methods have become deeply entangled with processes of world-making, through their crucial role in making inferences about the world. When deployed in contexts such as criminal justice, social welfare, or public health, predictive systems take an even more active role in shaping the world by directly feeding data-driven insights into decision-making processes. In such high-stake contexts, patterns generalized from observed data are rendered actionable, often embedding and exacerbating historical patterns of inequality and social harm. The project of remaking the world in a way that does not encode the past into the future in a perpetual feedback loop of discrimination requires an in-depth examination of the operative logics underlying some of the key machine learning methods in high-stake context. While practices of classification, inductive inference, and correlation-based predictive models all typically serve as useful instruments for scientific research, their use in sociopolitical contexts require additional scrutiny. The seminar will explore some of the key concepts and example components of machine learning systems by situating them in their implementation context and examining their epistemic functions. Each session will approach machine learning logic via a different conceptual lens to examine their necessary conditions for meaningful interventions in the world. I'm now going to pass the mic to Magdalena. So Magdalena, please take it away.
Thanks so much, Jorge. Thank you for this introduction. Can everyone see me and hear me okay? Okay, I see some nods. Good, I'm glad. So yes, my name is Magdalena. Thank you for the introduction, Jorge. And thank you to Vitor and everyone behind the scenes at the new center. And also thank you so much to Tom Moynihan for inviting me to teach this seminar. And I have some slides that I will share. So let's just confirm. Can you all see this? Okay, fantastic. Let me just make this. Okay, and can you see the slides changing? Okay, fantastic. Okay, so let's get going. So welcome to session number 1. So what we're going to do today, I'm going to start by giving you some general overview of what this seminar is about and some context, especially given that I don't know who's taking the class, who's in the room, and obviously the topic of AI is something that there is a lot of information about at the moment, so people have different preconception about what it means. So first I want to establish some general context and background so that we all know what we're talking about and why. And then I'm gonna just talk very briefly about the structure of the course, so what we're gonna do today and for the next 3 weeks, and how it's gonna be structured and put together and analyzed. Then I'm gonna spend some time focusing on the material for this week, so benchmark datasets and the logics of classification. And then I hope we'll have a bit of discussion. There will definitely be time reserved for that. of course, online teaching is always a bit tricky, so I don't know how usually it works out here, but I really hope that we can have a genuine discussion, so not just questions and answers, although of course I'm more than happy to answer any questions, but it would be great to have some kind of broader discussion where we can all focus specifically on this material for this session. So the logics of classification and benchmark data sets. I'm very curious to hear what people made of the reading and how they see the topics. And just a quick note that the student introductions will take place at the start of the next session. And of course, I'm really looking forward to it. I'm very curious to find out who's taking the class and why you're interested in this topic, and also what you already know about it, what you don't know, and what disciplinary background you come from, because of course it's a thoroughly interdisciplinary problem, and we all come with kind of different priors. So it'd be very interesting and fun for me to find out where you all stand and how you view the topic. But having said that, also a quick note, because I don't know at the moment who's taking the class and what your priors are, what you already know, what you don't know. This first session, especially this first part of the session, will be pitched at a quite introductory level. Simply because, yes, it's I don't know how much you already know about the topic, and I want to make sure that, especially from next week, where we really pick up the pace and we start talking about ideas that are perhaps more complex and maybe also less self-explanatory, less spoken about already than classification and data. So I really hope that today we can cover all the basics, and that next week we're all on the same page and we all know what we're talking about. But because of that, if there are some of you who are already quite familiar with the topic, you might find the beginning of the session a little bit, basic, low level. So apologies for that. I promise that we will pick up the pace, and also next week when we all introduce ourselves and talk about what our expectations are, that also will be a great opportunity for me to also adjust the level. If you want something a bit more advanced or a bit more basic, that can definitely be arranged. But today, bear with me, we'll cover the basics and then see where we take it further. Okay, so first, what this course is about. So very briefly, from that kind of short blurb that Jorge already read out earlier, I just wanted to pick up some of the key terms so that I can differentiate them from some of the other terms that are kind of broadly in the same universe. So we're talking about machine learning methods, and particularly on specific contexts such as criminal justice, social welfare, public health. So we're talking about predictive systems, these systems that try to make some predictions about the future in order to make some actions, take some actions in the present. And so we're talking about high stakes context. That's the kind of key term that is used to cover a lot of these contexts, such as criminal justice, social welfare, and public health. I guess it is quite self-explanatory. It simply means that any decisions taken in these contexts can have severe effects. They can affect the public, they can affect people's lives. And that also means that any mistakes or any, harmful decisions cause real harm in people's lives and society. And we're going to talk about how these systems very often embed and exacerbate historical patterns of inequality and social harm. So this is in a way that the kind of key reason why it is really important to still talk about these systems, because they still do have these effects and they are quite severe. Okay, so first, the machine learning versus AI. I chose this term machine learning simply because in this kind of simplest sense, as I put here a quote from Russell Norvick's Artificial Intelligence, the kind of key textbook, and they just point to the fact that there is confusion between the two terms, and machine learning is simply a subfield of AI. So some AI systems use machine learning methods to achieve competence, but some do not. So you can have AI that uses, especially some of those kind of older methods. So it isn't the kind of modern machine learning. So that's one aspect of it. It is a much more narrow term to talk about machine learning. But for me, also, I do prefer using that term, especially when talking about the kind of technologies that we'll be focusing on here. It is because the term AI brings up all of these other issues, all of the hype. It brings up all of those, floating signifiers like AGI, superintelligence, etc. And there is, and also a lot of the cultural imaginaries as well, which machine learning, the term itself, doesn't immediately trigger all of that. So for me, using machine learning is the term to kind of signal we are interested in the specific technology rather than the kind of hype and fantasies around them. Whilst at the same time, I think it's also completely fine if we use them interchangeably as long as we know what we're talking about and we understand what we're referring to. I myself sometimes use it interchangeably, so of course that's not a problem. And secondly, what kind of AI? So, there isn't a kind of clear and definitive taxonomy, but the distinction that is very often used for practical reasons, mainly, is the distinction between predictive AI and generative AI. So generative AI, of course, it's the type of AI that has been really popular over the last few years. Of course, ChatGPT was the product that really put it in the kind of public imaginary and triggered all of this interest about AI in recent years. So when we talk about generative AI, it would be a lot of the models that I'm sure a lot of you interact with as well. So it would be technologies that generate an output, whether it's textual, visual, audiovisual, sound output, but usually is oriented around generating an output. And predictive AI, whilst generative AI also uses prediction to some extent, predictive AI, it will be the systems that specifically are intended to make predictions. They don't generate new output, they just make predictions. So predictive AI makes predictions about the future in order to guide decision making in the present. So it's this very kind of simple but to the point definition from this book, AI Snake Oil, which I also uploaded some chapters for you. Okay, so in this course, we're talking about predictive AI. We're not talking about generative AI. And we're talking about predictive AI in high-stakes contexts, such as criminal justice, social or public health. And for the reason that we really want to focus on these systems that are really important, that still have very high stakes in the society. And whilst there is a lot of predictive AI, which potentially you could make the claim that they have severe stakes, I don't know, even recommendation algorithms or algorithms that predict whether the email you receive is important or not. There's a lot of predictive AI that at least on the surface is quite benign. We're focusing mostly on those kind of socio-political applications of predictive AI. So in short, the course is focused on ML applications such as predictive policing or pre-trial risk assessment tools, rather than things like LLMs, diffusion models, GANs, or the kind of general group called these days foundation models. So I hope that also already clarifies what we're doing, and that some of the frameworks we'll be covering will not apply as neatly to some of these examples of generative AI. So that's something to keep in mind. If you're interested in those systems, of course, there is some scope for us to discuss it a little bit, but the material that I prepared would be mostly applicable to predictive AI. Okay. Okay. So why is it important to think about predictive AI? So especially that these days everyone's interested mostly in generative AI. But in terms of the use of AI, predictive AI is still the type of technology that actually generates more revenue. So there's still a lot of companies working on such applications, and there's also some companies and investors that are trying to tell companies that they should focus more on predictive AI because it is the technology that does generate profit more than the generative AI that requires a lot more investment, and so far it's still a bit unclear like how well exactly it will translate to products that will generate long-term revenue. So that's one reason they still, predictive AI is still very much used, and it used intensely, and it's still considered to be the type of AI that generates revenue. But it's also, most importantly, consequential for society because it is part of what's generally called automated decision systems. So defined here by Rashida Richardson. Automation decision systems are data-driven technologies used to automate human-centered procedures, practices, or policies for the purpose of predicting, identifying, surveying, detecting, and targeting individuals or communities. In particular, these technologies are used by government agencies to allocate finite government resources, for example, public benefits or health services, or to foresee and presumably prevent specific risks or adverse outcomes, to remove or curtail discretion from current human decision-making, and to provide analysis at a scale and scope that cannot be performed by humans. These technologies are more colloquially known as predictive policing, pre-trial risk assessments, school assignment matching algorithms, fraud detection systems, traffic management systems, screening tools, or face recognition, end quote. Okay, so let's go over some examples, especially the ones that at this point are quite canonical. I suspect that most of you would have heard about most of them, potentially, if not all. So, of course, the probably most well-known example is this infamous tool called COMPASS, which stands for Correctional Offender Management Profiling for Alternative Sanctions, which was a tool developed by a company, North Point, and used in the US in some states to assess decision-making with regards to assessing the risk of recidivism by defendants. And this famous study by ProPublica discovered that this tool was very clearly racially biased, and their study actually checked, they continued checking on some of the people who were subjected to the use of this tool, and then they were giving an assessment like how likely they are to reoffend if released on bail, and then they checked, the researchers checked that a few years later, and it seems that the tool was just largely incorrect. It was very racially biased, and also it seems that even on its own terms it fails. That statistically it seems like it is no better than just random guessing. So not only a tool that is very clearly harmful to particularly marginalized groups in the society, but also on its own terms, just not very useful and doesn't deliver on its own promises. Another example that is quite well known is the famous system, or infamous, I should say, system developed by Amazon, designed to be an automated recruitment tool. And here in this case, it was very clearly biased against women. And for the kind of simple reason that it was mostly extrapolating patterns from past data, from past resumes of people who applied to work at Amazon, especially in the kind of IT sector, the kind of more managerial sector of Amazon. So again, it's usually IT skills which are usually quite gendered, or used to be quite gendered, and the tool was biased against women, was not recommending women as much. But what is particularly interesting about this case study is that it wasn't, even if there was no clear indication, there wasn't a marker for gender on a CV, the system was able to pick up on some proxies that that showed that the candidate was most likely a woman, and was able to to not recommend the person, or just in general kind of rank that candidate lower. So it penalized resumes that included the word women's, as in women's chess club captain, or if there were names of all women's colleges on the CV, that was already a kind of proxy for gender, and the system was able to pick up on that. There are plenty of other similar examples. So, for instance, there was this Dutch childcare benefit scandal. And there is I put a link if people are interested. All the links for more details are on the slides. I can upload the slides as well. And this is from an Amnesty International report that exposed how racial profiling was baked into the design of the algorithmic system used to determine whether claims for childcare benefits were flagged as incorrect and potentially fraudulent. And it was mostly penalizing low-income families. They were falsely accused of fraud by the tax authorities. And also people from ethnic minorities were disproportionately impacted. Similar story, even more recently in Denmark, an AI-powered welfare system was fueling mass surveillance and was discriminating against marginalized groups. And there are plenty of similar examples here. There's a comparison of what Narayanan and Kapoor call predictive optimization. So within the kind of predictive AI family of technologies, they also distinguish those that they call predictive optimization. So that specifically affects individuals directly or groups. So Compass would definitely be an example of it. There's this AFST, was a system in Allegheny County that was again trying to prevent family mistreatment of children, and it was penalizing people from lower income families and placing children into foster care. Simply because of bias, not because of genuine risk of the children being mistreated. There's also another example on this list that we're going to talk about more in later weeks. This Optum product Impact Pro, which was for assessing healthcare risks. So people with more complex care needs, healthcare needs, were supposed to be referred to this program so that they can receive proper care before they get to a point where they have to end up in a hospital and then, put even more strain on the system. And here again, the system was biased against typically marginalized groups on the basis of race and class, etc. And of course, there's predictive policing, which we're going to focus on the most throughout the course, mostly because it's the case study that I spent time researching and that I think is very important. And that also there is a bit more actual data and research available of some of those predictive policing products, especially from a company called Predpol, now called Geolytica. They rebranded some years ago. But they published some of the research, so we'll be able to also look at their own published research where they explain how the system is constructed, and that will give us also some material for analysis in terms of like how we can understand these systems. But again, just to very clearly define what we mean when we say predictive policing, I quote, predictive policing generally describes any system that analyzes available data to predict either where a crime may occur on a given time window, so place-based policing, or who will be involved in the crime as either victim or perpetrator, so that's person-based. And the latest iteration of data-driven crime analysis techniques that law enforcement agencies are increasingly relying on for crime control and forecasting. Few predictive policing vendors are fully transparent about how their systems operate, what specific data is used in each jurisdiction that deploys the technology, or what accountability measures the vendor employs in each jurisdiction to address potential accuracy, bias, or evidence of misconduct. Despite these looming questions, one known fact is that historical police data is the primary data source used to inform these systems. And while the specific data categories will vary by system, It can include information on past crimes, type of crime, time and location, arrests, and calls for service, end quote. So again, we have this pattern of the kind of historical data being then used to perpetuate a similar pattern in the future. And we're going to look more closely at this example in later weeks as well, because like I said, there's a lot of very interesting material that we'll be able to analyze. Okay, so it's important to point out that even though we don't hear about predictive AI as much anymore, mostly presumably because we hear about generative AI a lot, and also there have been all these efforts to regulate these systems, to put new legislation in place. Of course, most famously, the EU AI Act, the first legislation of this sort. And the kind of final version, the agreed upon version, was already, I think, published almost 2 years ago. There have been updates, but as of, I think, beginning of this week, it's supposed to be implemented. But then again, it's there's still time for countries to put in place systems to check that it's been implemented, etc., to adapt. So sure, we have a lot of this new legislation, and it's important to say that in this legislation, some of these uses are technically banned or restricted. So for instance, facial recognition software is almost entirely banned. There are restrictions on predictive policing. There's a lot of restriction on some of these systems that we'll be looking at. However, as with most legislation of this type, the EU AI Act includes major loopholes, especially for the types of technologies that we'll be talking about, so especially for police, and especially for the kind of national security exemptions. So a lot of people point out that it's a similar story as with GDPR, the kind of data protection legislation that in theory protects individuals, but there's always this exception about national security, about potential, terrorism threat. And as we all know, the people who are then flagged, who do not enjoy these kinds of rights, are usually the same people, the same marginalized groups. So if we're already seeing that these tools mainly target and harm particular groups who are typically marginalized, even with this legislation, they potentially are not enjoying the same protections as other groups who are not typically marginalized. So predictive AI and these uses are still very much a pressing concern despite all of this new regulation. And there have been some activist groups and specific NGO bodies that have been campaigning for amendments and for changes in the EU AI Act, and specifically pointing out that it contains those loopholes that allow for dangerous precedents for harmful surveillance by police and migration authorities. And that what they say here is that it creates a kind of parallel legal framework when AI is deployed by law enforcement, migration, national security authorities. They can still operate within the space of these loopholes, and therefore all of these technologies are still very much a concern for the society. Okay, so of course, everything that I've just been talking about presumably is not news to anyone. I don't know to what extent you're familiar with all these examples and all these issues, but I'm sure that you have at least some understanding of these problems. And of course, in the kind of broadly conceived area of, critical AI studies or critical data studies, critical algorithm studies, and the kind of the humanities, critical approaches to technology, there already has been a lot of discussion of these problems for many years. So even, before some of these systems, these kind of ML-based systems were implemented, these concerns were already related to just simpler algorithms and, to collection of big data, and profiling people, etc. So I put some of those most known works in that genre here on the screen, and they also afforded us some critical terms that I feel like they have become now also part of the kind of critical AI vernacular, like weapons of math distraction, or Virginia Eubanks, who talks about this Allegheny County tool for flagging the risk of domestic abuse of children. She coined this term digital poorhouse, so also tracing this idea of a poorhouse, like already marginalizing certain populations. We are talking, of course, about techno-chauvinism by Meredith Broussard, or algorithms of oppression, digital redlining, correlating eugenics. Also, I think I even put that chapter up from Wendy Chan's book. So already we have a lot of vocabulary to talk about these issues that we have from that kind of critical thinking around them. Okay. So we already have the kind of critique of the problems with data, of the bias in algorithms, of this idea that people create these algorithms, so they'll be as biased as the people who create them. The data collected is already biased, even if not directly, has those proxies, as I explained in that example from Amazon. There's also a lot of critique of this this veneer of neutrality and objectivity. So very often there was this narrative that because it's an algorithmic system, it's just maths. So, it's objective. It's not actually human judgment involved. There's also the very real concern about the lack of transparency and the fact that a lot of these systems are proprietary. That is the private sector that provides these products to governments. So to a large extent, it is quite difficult still to scrutinize the data, the models, the results, etc. So these are all very real concerns, and we have a lot of this critical vocabulary to talk about them. However, at the same time, the problem is that it seems that this critique is really not breaking through. And in the kind of more computer science approach, in the kind of ML community approach, there's even a lot of talk about, fairness, accountability, transparency, and ethics, the kind of FATE research. There are efforts to remove bias, to de-bias algorithms, etc. And I don't know to what extent people are familiar with that, but it is usually just trying to make these concepts such as fairness or equality, to make them measurable, to make them computable. So of course, in the humanities, that is a very obvious problem to us, that it is difficult to design a metric by which we can assert that something is fair or equitable. However, by nature of the kind of style and orientation of the discipline where these systems are made, so in computer science and the kind of software engineering, it is quite difficult to translate some of these concepts into something that genuinely could make these systems better. And that of course delves into question of the key values in different disciplines. So for instance, I put here that some researchers in the kind of human-computer interaction discipline, they analyzed 100 most cited papers from 2 leading ML conferences, and they showed that the values that are most valued in ML research are things like, sorry, I put 2 copies because it's just one image. It goes all the way down, but of course it doesn't fit on a horizontal slide. So you can follow up to here, and then you will see how it moves to the side image. But as you can see, the values that are most important for the ML community: performance, generalization, which is again this capacity of a system to generalize a key pattern from a data set and be able to use that to then perform well on new inputs. So it's something that also we're going to talk about that more next week. We're going to have a kind of more in-depth overview also of the structure of a machine learning model. But yeah, generalization is very important for the model to perform well, also building on past work and, you know, providing quantitative evidence, being efficient, some aspect of novelty. Whereas these values that the researchers here classified as user rights or ethical principles, so you can see in the kind of blue and orange, as you can see, they at the very bottom and you know, are really not discussed and not prioritized by these leading papers in machine learning. So we can already see that these values and these priorities contradict this idea that maybe we should, you know, slow down and have systems that maybe, you know, are not implemented to that extent. So maybe they don't perform as well in the kind of computational sense, but maybe have different priorities, more societal priorities. So of course, this I'm kind of giving you an overview of where I kind of sit in this whole discourse and why the material that I put together for this course, the seminar, why it's structured the way it is. As I think, you know, it might look a bit eclectic. There is a bit of, you know, critical AI studies. There is some analytic philosophy. There is some philosophy of science. So it might look quite eclectic. However, in my research, like why I ended up with this material actually making a lot of sense for understanding machine learning, especially those predictive systems in high stakes contexts, is because of this separation between the critique and the kind of humanities approaches and the, you know, the computational orientation of that everything has to be computable and what priorities machine learning as a niche within computer science discipline has. And I started looking for some of the shared concerns because there are many shared concerns. So for example, concerns around the lack of a clear theoretical basis for many machine learning methods. That's again something we're going to cover in a bit more detail next week, because there have been for many years many ML researchers who were very alarmed by this technology being seemingly operating on a trial and error basis, not having this theoretical grounding and having a clear theory that explains why things work and when they work and when they don't work. So that is a concern within the discipline, not just something that we're concerned in terms of what effects these technologies might have. Also, this the concept of prediction that is quite problematic in machine learning. Of course, from our perspective, predicting if somebody will commit a crime is, of course, quite obviously problematic. But even with it on its own terms, within machine learning research, there's a lot of concern about conflating prediction with explanation. That's something that those researchers are interested in unpacking and in having more rigor around as well. And of course, this reliance on correlations and thinking how we can start searching for systems that could be causal in nature, that could utilize and generate and collect causal knowledge. And is that even possible? There's, of course, a lot of work that is being done on it, and that's something that we're going to focus on predominantly in the final session. But again, this is something that both the machine learning engineers and scientists and people in the humanities are very much interested in. So despite the fact that ML-based predictive systems often involve complex models that make it challenging to fully account for every detail of their operations, the general process by which they produce predictions is well understood. New data inputs are processed by a model generalizing patterns found in the training data. So again, this idea that has been quite popular and thoroughly discussed about the idea of a black box, about these systems being opaque and difficult to understand and explain. whilst it's true to a large extent, especially in relation to the proprietary nature of some of these systems, them being products produced by companies that then keep that as their own IP, that is then positioned as this kind of barrier that, that you can't scrutinize these systems because they're black boxes. In a sense, if we approach it from the point of view of these concerns, okay, we are trying to figure out the theoretical basis, why these systems work, why they don't work, when does it work, when it doesn't work. Actually, we can take it down to these most basic levels. And in terms of, okay, we have new data inputs processed by a model, generalizing patterns found in the training data. So a lot of the kind of theory, the kind of broader theory is statistical learning theory. And also it is inductive inference. So that also gives us a kind of way into these systems in terms of, okay, we want to, on a broader basis, we want to be able to evaluate on a more abstract level. So rather than just being constrained to just finding out post hoc whether there is a very harmful system that has been operating already and it caused all this social harm, and always playing this catch up with the companies, and there being no overarching way of understanding these systems in order to figure out and very clearly point out ahead of time that the system is problematic and in terms that are understandable to people who come from computational disciplines, from more scientific disciplines, rather than from the humanities, talking about it in a way that can show on their own terms whether these technologies are suitable for particular uses or not. There are those ways that I'm kind of putting here for your discussions, especially over the next 3 weeks, that we can approach these systems from the point of view of their underlying logics, and in that way try to show which systems should just not be used, that there's no justification for them, and where there is more gray area that that we could potentially have a broader discussion whether recommendation algorithms are problematic or not. Okay, so this is a kind of a background of the context, the main objects, why they're important, and in a sense why the material that that you've got in the syllabus is structured the way it is. It's because this this course very much takes, of course, my point of view, which is that we can look at a lot of this literature around philosophy of science and theories of induction and causation in order to make very specific claims about predictive AI. And that also will be potentially very much aligned with some of the concerns that we have in the humanities. Okay, so just very briefly, you have that same material in the syllabus, but just very briefly to explain how the sessions are structured. So today, of course, we had the session on benchmark datasets and the logics of classification. This is, I guess, the kind of the most straightforward and self-explanatory material of this course. So I hope that already, if you have read the text I assigned, it's already pretty clear how the logics of classification interface with these systems, why they're important, why they're consequential for the effects of these systems in the world. So I'll still go over this material a little bit, but hopefully that was kind of easy enough that you already see how that all fits together. And yeah, just you probably already know this, but the kind of reading I assigned for each week is in those 3 categories. So core reading, this is the text that I would like you to read and that we will be discussing. And then I have these optional readings that are just very, very entry level. So if there are any of you who genuinely have not come across much of the material before and would like a very easy to read primer and summary of some of these case studies and problems, then I have some of those very easy to read introductory texts as well. And then some reference material, which is mostly, a lot of these papers are quite technical, and we won't be looking at them in detail. I'm not asking you to read them, but they usually are papers related to the kind of key concepts that we will be discussing each week. So some of them I might also put on the slides, and we might analyze some aspect of technology or concept that the papers relate to. But yeah, they're not meant to be read in full. You can ignore all the maths and all the technical stuff because that's not what we're going to be focusing on. But I uploaded them for your reference because I think it might be useful to then know what we're talking about, where it comes from. Okay, so session 2. So from next week, like I said, we will hopefully pick up the pace a bit and really dive into those more kind of meaty philosophical approaches that we will be applying and kind of operationalizing in relation to predictive AI and in relation to also case studies. So next week, we will discuss predictive policing a bit more, because like I said, that will be a case study where we can already very clearly see how the theory that we'll be reading might be applicable to these case studies. So we'll be focusing on theories of induction, like I already highlighted before, if we're trying to summarize or maybe abstract on a certain level how predictive AI works, the most basic rule we can point to would be inductive inference. And for me, especially in my research, coming across this a work by Norton, the material theory of induction, has been particularly useful for thinking about predictive AI. In induction, it's important to say there is no consensus. There isn't like one theory of induction that everyone says, yes, it is the correct one. There are, of course, different camps, and, we'll talk about some different views of induction. So, of course, I'm not saying that Norton's account is the definitive one. However, the text that we will be reading also gives an overview of how Norton thinks about these other theories of induction, why he proposes this view that any induction is local, that we can only justify inductive inference locally by way of material postulates, material facts. In a way, we could say, in the context of machine learning, a kind of domain-specific knowledge. So again, this, as you start reading it, it might already start sounding like something that is, in a sense, similar to some of the discussions that happen around machine learning. And also, we will focus on this concept of the no free lunch theorem. So again, as much as we don't have a kind of robust theory underpinning machine learning, there is this theorem, no free lunch theorem, which states that there is no free lunch. You have to, there is no master algorithm. There isn't one method, one algorithm that delivers the best results. Each algorithm, or a learning method, comes with its own let's say, not biases in the kind of humanity sense, but its suitability for specific tasks more than others. So the theorem says that on average they all work the same, simply because there will be some contexts where certain algorithms work well, others fail. So on average they might be all similar, but that means that the learning methods will vary, and we can't always use the same methods for different problems. There's no free lunches, and you have to bring some prior knowledge. You have to bring some understanding of why certain method would work. So in computer science, in machine learning, that is quite nicely theorized, and it shows very clearly that, there are always some preconceptions that go into the process of developing machine learning models. And that very nicely ties in with this view of induction, that induction is always local, that we always need to justify inductive inference with material postulates, as in from kind of domain-specific knowledge. So we will look at those theories, and we will also look at them in relation to predictive policing. So I also put this in reference materials. I put the paper on the no free lunch theorem, but also the first research published by the two researchers who founded the predictive policing company that used to be called Predpol. So we'll also see how they talk about the system and how they conceptualize their particular method So I hope we can have some fun in looking at the rhetoric around it, and then also using these tools of induction, especially Norton's view of induction, to be able to analyze critically the logics behind some of these systems. And also, you know, my cards on the table, where I stand, and I hope, you know, that with this theory, you will see that as well, is that using these theories, we can show that there are certain contexts where predictive AI is just fundamentally unsuitable for. There's no justification for using it. So we don't have to wait for another system to be developed and implemented and then show how many people are harmed. We can actually distinguish between contexts, that there are certain problems, certain contexts where these systems are fundamentally unsuitable for and cannot be justified. Okay, and then in week 3, we will engage more with the question of the model, and we'll look at philosophy of models and theories of models in the philosophy of science. And we will also talk about, you know, idealized models and false models. This famous maxim by George Box that all models are wrong, but some are useful. Of course, people in the ML community always love this phrase because that, in a sense, gives them this license to just, you know, do things trial and error and then see which models are useful. Even if, you know, we can agree that they obviously not perfect, you know, representation of the data. That also is a kind of question of overfitting and underfitting, which we're going to discuss more next week. But we're going to talk about what is a model and how the theories of models that we know from the philosophy of science can also help us think about models in machine learning. And especially the case study of predictive policing will be additionally interesting because the company that founded Predpol, the researchers that founded Predpol, they used a model that was first developed for modeling earthquake patterns. So we can look very closely at that research. We can look at how this model has been used in its original context and how it was developed, and how, you know, there are certain ways of working with these models in the source discipline of a model, which is, you know, in the geosciences. So that's why also I put in the reading Elisa Bakulic piece on scientific models and explanation, but she specializes in the geosciences. I also have in the optional reading, there's a whole kind of chapter about models and geosciences. Again, it is quite synoptic. It is not, you know, it doesn't have this kind of philosophical depth. So it is just more synoptic. It might be easier to read if you want to see a more a kind of broader overview of the different theories in relation to models in the geosciences, and also the question of prediction, explanation, etc. So yes, we will focus on models in machine learning and how the kind of thinking about false models and idealizations and explanation and prediction, how we can apply that knowledge to thinking about machine learning models, and how it can be useful, again, in pointing out very clearly on even more abstract level why machine learning models, predictive models, are fundamentally unsuitable for certain contexts, and also like how they're ultimately used in a way that typically, you know, scientific use of models does not agree with. So that's session 3. And then the final week, we will focus on questions of correlation and causation. And you know, we will, of course, as we all know, correlation is not causation, but in machine learning and predictive systems, it is particularly important to remember that and to really discuss that, because this statement that correlation is not causation is something that, again, features quite prominently in critical discussions of these technologies. But there is very little, if any, ever engagement with causation. So, okay, what would it mean to have a causal model? What would it involve? Is it possible? Like, what are the considerations in relation to it, especially that in machine learning, in the field, people are working on causal ML. They have been working on it for many years, and and it seems like the field is ready to show, okay, we can have causal models, so it's fine. We don't have to worry about correlation, but that's why it's really important to think about what that would involve and what would be the conditions for a genuine causal knowledge to be operationalized in these high stakes contexts. And again, in particular, we won't be looking at all theories of causation because, again, some of them are more relevant than others to the systems we're looking at. So specifically, we'll be looking at the so-called interventionist theories of causation. So especially Judea Pell, who is the kind of foremost scientist behind thinking about causation, but also thinking about causation in relation to machine learning. He's skeptical that that can be achieved, but we'll discuss why. And also interventionist causation from kind of philosophical side, from James Woodard. We will read the introduction to his book Making Things Happen, A Theory of Causal Explanation. And that again, it's talks about the conditions for intervening in the world. And that's why it is very relevant to predictive systems in high stakes contexts, because they usually come with this interventionist premise. They usually say, okay, we want to intervene in certain processes, whether it is, processes of crime or processes in fraud, etc. The rhetoric of intervention is already there. And theories of causation, especially the interventionist theories, give us very specific analytical tools for showing when intervention is possible, that you do need to have causal knowledge in order to make meaningful interventions, that predictive models are fine with correlations, that you can make successful predictions with just correlation and kind of correlation-based data, but you can't make interventions. So again, if you want to intervene in the world, you need to have causal knowledge, not just a knowledge of correlations. So again, the literature that I selected will help us then look very clearly. Again, we will look a bit more closely at some of the research published by a predictive policing company, so that we can see very clearly the kind of causal language they use versus, what the technology really does, and why it definitely isn't related in any way to accumulating causal knowledge and acting on that knowledge. And I also put a chapter from the kind of critical AI studies side of things from Wendy Chan. This chapter correlating eugenics, so also we can think very clearly not just the kind of abstract questions of causation, but also in terms of the kind of societal costs and what happens if we just base on everything on correlations. And also it traces a little bit of the troubling history of some of these methods that underpin a lot of these data-driven systems. Okay, and a very quick note on assessment for this course, of this seminar, sorry, the terminology. So yeah, for those of you who are interested in taking part in the assessment for this course, there are presentations and final work, as I'm sure some of you are already used to. From what I understand, the presentations typically are around texts. And as I already discussed with Jorge, because of the nature of this course and because, the reading is a bit eclectic, there is a bit of philosophy, there is a bit of critical theory, there are some, more specific case studies, there are shorter texts and longer texts, and they also differ in the disciplinary orientation and in potentially level of difficulty. I'll be very happy for you to choose whatever makes sense for you. So if some of you want to, work on a summary of a text, if that's useful, sure, go ahead. But also if there is just a particular concept in a text, or just there's an aspect of a text that you find interesting and you want to do something useful with it for you, then please feel free to organize your presentation around that. Like, it doesn't have to be very, closely related to the text. It just, from what I understand, it has to have some relation to the text so that, the people can sign up for the presentation. So for that process to be easily managed, there has to be some way of assigning these categories. But in terms of the content, please just do something that is useful for you, that makes sense for you, and then we can discuss that. And then also to point out that I would like the presentations to be all pre-recorded and uploaded, so that we will have each week we'll have lots of time to have a discussion in class. We can watch the presentations outside of class, but all the time that we have together when we meet, we can spend on going through the material and being able to discuss it together. I think that might be the best and most useful use of our time together. And then the final work, again, I don't
Sorry,
really.
Magdalena, maybe I
Yeah.
will say a word here.
Yeah.
So for the students, there is already in the Google folder, there is a sheet where with text from the second week. So there you can, I will just copy paste also here. So then you can inscribe your name there. And then we will find, following, I guess, Magdalena, you will find a way how you select the text, and you will find a way how to present, you create something that is to be presented. But the sheet is there, and then just find the text, and I think it's self-explanatory if you put your name so that we know that you are selecting one of the text from the second week.
That's great. Thanks so much for that. Yes, please do. Those of you who want to do those presentations, please sign up there. If you have any questions about any of it, please feel free to email me whenever. I will very happily, discuss ideas with you and suggest other texts, or, just feel free to drop me an email if you have any questions or comments or anything like that. And yeah, just quickly on the final work, it can be written, it can be audiovisual. It should pertain to some aspect of the course, of course. So, you could focus on a case study that, maybe we haven't discussed as much here. So, it doesn't have to be predictive policing, but some of these other examples of predictive AI that I discussed, I can, there are some papers I think that I already uploaded to the kind of optional material or reference material, but I can also provide you with more of these publications. So if you want to take a case study that we haven't discussed as much, but also follows a similar, has similar problems and operates in a similar way to the case study we're discussing, then you can do that, and then you can pick one of the approaches that we discuss in the following weeks. But you can also just do something that's relevant to the course, and that's also relevant to your interests and your disciplinary orientation and training. And like I say, the requirements are very flexible, and feel free to drop me an email, discuss your ideas with me ahead of time. The deadline, standard deadline, so a week after our final session. Of course, if any problems, drop me an email. But yeah, ideally, if you could all submit, then it would be great, and then we can I can mark them, and we can have this process kind of whilst the material is fresh. You can then work with these ideas. I think that would be preferable probably for you as well. Okay, so are there any immediate questions on the overall structure of the course? Like I said, you can always email me and presumably the New Center guys about anything technical, so that we can discuss later. But if something is unclear, let me know. Otherwise, we'll just jump into the classification, etc. I can't see anything, so if there are any questions, maybe just unmute yourself. If not, I will just keep going. Okay, I hope that means everything's clear. And like I said, there will be definitely time for questions down the line as well. Okay, so just to discuss at least a little bit the material that you've read for today. So the material around classification, the logics of classification, and its relation to the use of data in machine learning, and to very specifically as well, training data and the so-called benchmark data sets. I think that the readings I selected, I hope it already is quite clear how it all fits together, because like I said, it's this way of looking at things. It's not it's not a groundbreaking idea. I think it's already within this discourse. It's something that already people are aware of these logics of classification, and how they very often underpin predictive AI in a lot of these systems. But very quickly, as a refresher again, so we have the same priors going forward. So the text, of course, the Einstein is the kind of classic for thinking about classification and its consequences. So Sorting Things Out by Jeffrey Bowker and Susan Lee Starr. And you've read also a text that already discusses some of these ideas in relation to ML data, and especially the kind of canonical benchmark dataset called ImageNet, as well as some other machine vision canonical data sets and how they were constructed. But ImageNet is really the one of those canonical examples that has been discussed at length, but it is really quite illustrative of a lot of these problems that are very much underpinning problems with predictive AI. And this also in some way applies to generative AI as well. The question of data is, of course, important to all kinds of AI and more broadly data-driven systems. But just so we can go over the specific ideas and framings from Bowker and Starr, that I think it would be good for us to keep in mind, and that illustrate the kind of key arguments around the problems with data and classification in ML. So I put a fragment here on the screen. I hope it is still legible on your screens, but like I said, I can upload the whole presentation to the Google Drive as well. So the introduction is to classify is human. So already this proposal that classification systems are very much part of human experience, part of how we organize our society, how we operate on the day-to-day. So they write on page 3, and I quote, "But what are these categories? Who makes them and who may change them? When and why do they become visible? How do they spread? What, for instance, is the relationship among locally generated categories tailored to the particular space of a bathroom cabinet, and the commodified, elaborate, expensive ones generated by medical diagnoses, government regulatory bodies, and pharmaceutical firms?" Of course, the context here is medical, because as you've read, that's the kind of key case study, the key example that they use in the book to show some of these problems and issues with classification. But they also say, "Remarkably, for such a central part of our lives, we stand, for the most part, in formal ignorance of the social and moral order created by these invisible, potent entities. Their impact is indisputable, and as Foucault reminds us, inescapable. Try the simple experiment of ignoring your gender classification and use instead whichever toilets are the nearest. Try to locate a library book shelved under the wrong Library of Congress catalog number. Stand in the immigration queue at a busy foreign airport without the right passport, or arrive without the transformer and the adapter that translates between the electrical standards. The material force of categories appears always and instantly." So again, this way of thinking about these categories and these labels that might not be the primary focus of talking about data, especially in the kind of big data imaginaries, that is just a deluge of data, that it's somehow magically is then later processed to have useful insight, to have insightful knowledge, and it's there's this veneer of things just flowing and not being specific and not being so clearly classified. But there is definitely this very material force of categories that appears always and instantly, especially if they're ignored, or especially if they're not so clearly communicated. So of course, in the context of training data used in AI, predictive as well as generative, it's not something that we think about. It's not the information about how the data is initially classified is also very often not the kind of information we have access to. So usually that material force of these categories appears when these systems act in their environment, have effects in the world, and that's when the kind of material dimension of them becomes visible and kind of palpable as well. So they also provide lots of other examples, and especially most of these examples, of course, as always, the categories and standards usually affect the most negatively affect those who are already marginalized, whose official categories, whether it's race or gender, is already the category that is suffering from the most harm. So they give examples of the decision of the US Immigration and Naturalization Service to classify some races and classes as desirable for US residents and others as not, resulted in a quota system that valued affluent people from Northern and Western Europe over those, especially the poor, from Africa and South America. I guess, we all see the contemporary analogs, maybe even more extreme analogs of these situations in our current political events and discourse. So of course, this is, I think, quite self-explanatory in terms of how these categories have these very material, very often corporeal impacts. And when they talk about classification, they try to define the concept. They say on page 10 and 11, they say, a classification is a spatial-temporal or spatial-temporal segmentation of the world. A classification system is a set of boxes, metaphorical or literal, into which things can be put to then do some kind of work, bureaucratic or knowledge production. In an abstract, ideal sense, a classification system exhibits the following properties. One, they are consistent, unique classificatory principles in operation. Two, that categories are mutually exclusive. And three, the system is complete. And of course, they say that no real-world working classification system that they have looked at meets these simple, quote-unquote, requirements. And Walker and Starr say they doubt that they ever could. And the same goes for standards. When they talk about standards, they say the control, I quote, the control of standards is a central, often under-analyzed feature of economic life. It is key to knowledge production as well. Latour speculates that far more economic resources are spent creating and maintaining standards than in producing pure science. There are a number of histories of standards that point to the development and maintenance of standards as being critical to industrial production. But at the same time, just as with classifications, these dimensions of standards are in some sense idealized. They embody goals of practice and production that are never perfectly realized, like Plato's triangles. The process of building to a standardized code, for example, usually includes a face-to-face negotiation between builders and inspectors, which itself includes a history of relations between those people. Small deviations are routinely overlooked unless the inspector is making a political point. The idiom, quote, good enough for government use, unquote, embodies the common sense accommodations for the slip between the ideal standard and the contingencies of practice. And again, we can talk about, what's good enough. It's, of course, also a very widely discussed and analyzed phrase in software development, and of course also in ML engineering, and what's good enough and who decides, and then who are the the data points out of distribution, like what's good enough and what does it cover and what are the effects of it. So by reading the scholarship on classification like Bowker and Starr, we can also make these connections of how these processes are always tricky, and therefore if operationalizing them in the context of machine learning and in these systems means that we have to do an additional layer of kind of digging through what's going on, because there, in a sense, these classifications are even more obfuscated. There's another layer, the data is processed, also a classification system. Okay, there's a task of classification, but again, there are many steps involved that mean that we can already have this understanding of classification as a process that already is very politically charged. And then in the context of machine learning, we have to do this extra work to also, show very clearly how the same process is happening, but they obfuscate it even more. Okay, and then I paired this text for you with a chapter from Kay Crawford's Atlas of AI. I think you already see how she already works with these ideas and applies them in the context of classification and its relationship to bias in machine learning. So she says, understanding the relation between bias and classification requires going beyond an analysis of the production of knowledge, such as determining whether a data set is biased or unbiased, and instead looking at the mechanics of knowledge construction itself, what a sociologist, Karin North-Cetina, calls the epistemic machinery. To see that requires observing how patterns of inequality across history shape access to resources and opportunities, which in turn shape data. Then data is then extracted for use in technical systems for classification and pattern recognition, which produces results that are perceived to be somehow objective. So again, this idea of, the veneer of objectivity, that it's just maths, so it can't be biased. And she says the result is a statistical Ouroboros, a self-reinforcing discrimination machine that amplifies social inequalities under the guise of technical neutrality. So again, by now, I guess it's also an idea that we're all familiar with, but being able to point specifically to this trajectory of the classification system and how we can see them in the data set, especially when it's labeled. In order to be processed, it has to be labeled. We're going to talk a bit more about the machine learning pipeline next week, but I hope that these ideas are already quite clear and self-explanatory in terms of how these the kind of politically charged nature of classification is already operationalized and has effects in the context of machine learning. So you just very briefly, again, I suspect we all know that, but just to cover all the all bases, why data is so important. We are going to talk about machine learning pipeline next week a little bit more, but of course, in order to this kind of very rudimentary sketch of the machine learning pipeline. So, in order to have some kind of output, so reading from, from right to left, in order to have some kind of output, there needs to be a model, and in order to construct the model, data is required. So, some collected data then is processed by a particular learning algorithm or learning method in order to construct the model and in order to classify or produce future outputs. And then also there's testing data, which again we're going to talk about more. But without data, there's more and more discussion about synthetic data. So not necessarily theoretically all data has to be collected in the wild or scraped or produced or what have you, but you need data, you need a lot of data in order to generate, to develop machine learning models, especially the kind of models that since the kind of deep learning revolution are the most successful. You need a lot of data for that. Therefore, is the key resource, and therefore it really matters how the data is classified, processed, etc. So yeah, because the success of machine learning, you know, in the recent, say, decade, just over a decade, is directly related to the increasing availability of data. So of course, it's not just data, it's also the computing power. So, you know, better hardware using GPUs instead of CPUs made it more possible to have more compute and to be able to do a lot of parallel computing and for these machines to just be a lot more efficient and to perform a lot more computation. So of course, it was not just data, it was also hardware. And it was also, you know, development and improvements in some of the methods that previously didn't work so well. So the idea, you know, for deep learning has existed before, but the availability of better hardware and much more data made it possible to see that these methods are actually really quite effective and really quite successful. But important to note that in the 21st century, there's clearly this shift in terms of how the data is collected. So the shift away from consent-driven data, so the kind of data that, you know, traditionally collected by way of surveys and polls and focus groups, etc. And now it's since a lot of since the kind of widespread datafication and a lot of our activities being online, we produce a lot of data online. It's very easily scraped. It is used as the training data with or without consent. And I have these two images as a comparison. So the top image is the MNIST data set, which was the one of the early machine vision data sets with their handwritten numbers, so trying to train machines to be able to recognize these handwritten numbers better. It was not a very large data set, but it was used very intensely for the earlier machine vision experiments. Now, of course, we have lots of visual data, and some of the important data sets have been discussed in the text as well, but yeah, definitely a lot of the data you know, trained on very a lot of containing images of you know, attractive white people, like Hollywood celebrities, etc. So of course, not very representative, not very diverse data set, and used to train a lot of the, especially the earlier machine vision systems. And of course, ImageNet, one of the most famous and canonical benchmark data sets. And sorry if I haven't explained this. So benchmark data set, it means that it's a data set that a lot of that is made available to researchers, and they can all test their new systems and their new methods to check the performance, how well it performs on that particular data set. So that is definitely still very much the case that even though ImageNet itself, you know, it's a relatively old data set now, while still, you know, being used. And this idea of benchmark data sets, if anything, there's just more and more benchmarks produced all the time, especially with generative AI. There are whole kind of families of data sets. So there are benchmarks that are just on specific tasks, and there are, you know, it's no longer just one data set that the system is tested on, whether it can accurately classify images. Of course, the benchmarks get more and more elaborate these days, and it's also something that, you know, we can talk about. But yeah, benchmark, it means that it is the benchmark, that the models, new techniques and new models are tested against the performance of, you know, the highest performance so far of other models tested on those particular data sets. And yeah, ImageNet is one of the most famous ones. And I put here a quote from a project, Excavating AI. It was a project by Kay Crawford and Trevor Paglen that also had this exhibition at the Barbican that the image is from, but I'm pretty sure that you've come across some of at least the visual material in relation to this project. But they contextualized the data set saying, a quote, in the words of its co-creator, Stanford professor Fei-Fei Li, the idea behind ImageNet was to map out entire world of objects over several years of development, ImageNet grew enormous. The development team scraped a collection of many millions of images from the internet and briefly became the world's largest academic user of Amazon's Mechanical Turk, using an army of piecemeal workers to sort an average of 50 images per minute into thousands of categories. When it was finished, ImageNet consisted of over 14 million labeled images, organized into more than 20,000 categories. For a decade, it has been the colossus of object recognition for machine learning and a powerfully important benchmark for the field. So again, why this was so meaningful at the time? It's because it was again, as they say, they used Amazon Mechanical Turk, so obviously the crowd working platform, because previously a lot of universities would just pay grad students to do data annotation. And of course, even though presumably weren't paid very well, it was still relatively expensive for the university, and seeing that they can underpay and exploit crowd workers on a platform like Amazon Mechanical Turk suddenly provided for them this opportunity to do a lot of this data labeling on a large scale, and for it not to be that expensive. So that was the rise of these crowd working services and platforms made it possible for them to have this large scale project. And that's why it was such an important development to suddenly have a data set that had all of these images that were labeled. And this data set quickly became a critical asset for computer vision research. It became the basis for an annual competition where labs around the world would try to outperform each other by pitting their algorithms against the training set and seeing which one could most accurately label a subset of images. And in 2012, a team from the University of Toronto used the convolutional neural network to handily win the top prize, bringing new attention to this technique. That moment is widely considered a turning point in the development of contemporary AI. So yes, in 2012, the project called AlexNet was entering into the competition, and that is, the kind of rough day that everyone talks about, the breakthrough word that really put deep learning on the map as the kind of most successful method and technique, and people started doing more work in deep learning, and this data set is very much part of that history, and the competition that AlexNet was entered into in 2012 is therefore such a pivotal moment for the field. Okay, so as you've read in the Crawford piece, the ImageNet data set, to begin with, it contained all of those very problematic categories around the category of a person. So of course it had some very derogatory categories that she discusses in the text, but as she points out, it's even the categories that are not problematic per se already point to the problem with classifying images of people into particular categories, especially that in the second quote that I put on the slide from page 142, she writes, the entire taxonomy of ImageNet reveals the complexities and dangers of human classification, while terms like microeconomist or basketball player may initially seem less concerning than the use of labels like spastic, unskilled person, etc. We look at people who are labeled in these categories, we see many assumptions and stereotypes, including race, gender, age, and ability. In the metaphysics of ImageNet, there are separate categories for assistant professor and associate professor, as though once someone gets a promotion, her or his biometric profile would reflect the change in rank. In fact, there are no neutral categories in ImageNet because the selection of images always interacts with the meaning of words. The politics are baked into the classificatory logic, and even when the words aren't offensive, ImageNet is a lesson in the sense of what happens when people are categorized like objects. But this practice has only become more common in recent years, often inside the tech companies. So again, what she points to this idea that there are a lot of these categories, they're not visual concepts. So that's already a problem. And then very often these categories come with certain prejudices and preconceptions. So it's even more of a problem, and some of them are actively derogatory. But as she points out, this has only been getting worse because now increasingly companies don't even allow open access to a lot of these data sets. They very often don't disclose what kind of data especially the current big, models in Gen AI are trained on. So very often it's even more difficult to scrutinize to what extent that might still be happening, and what that implies. I also put an image from a project by Kay Crawford and Trevor Paglan, who were here on the screen, when they were looking at this data set and finding out all of these categories that exist there and how the images were classified. They constructed this project. I think it's no longer offline, but it was called ImageNet Roulette, where you could upload a photo and see what it would be classified as. So as you can see, a lot of very interesting categories, again, not typically visual concepts. So yeah, this art project was also very helpful in making this idea kind of more well known of these problems with a lot of these training data sets that underpin a lot of the big developments in the field. Okay, so sorry. So just to kind of tie it back into thinking about logics of classification, Crawford writes on page 139, quote, "While these classifying logics are treated as though they are natural and fixed, they are moving targets. Not only do they affect the people being classified, but how they impact people in turn changes the classification themselves. And this is what Ian Hacking calls the looping effect produced when the sciences engage in making up people." So again, the categories that, people being categorized in a particular way, especially also in the context of, classification of mental health conditions, etc., very often kind of like are affecting these persons becoming so for intents and purposes. I continue with the quote. Bauke and Starr also underscored that once classifications of people are constructed, they can stabilize a contested political category in ways that are difficult to see. They become taken for granted unless they are actively resisted. We see this phenomenon in the AI field when highly influential infrastructures and training datasets pass as purely technical, whereas in fact they contain political interventions with their taxonomies. They naturalize a particular ordering of the world, which produces effects that are seen to justify the original ordering. And again, I also put some links. I don't know if people are familiar with these already, but Kay Crawford, this project Anatomy of AI, this large diagram of the kind of life cycle of a smart speaker. And some of these questions of classifications on how they fit into that process are very nicely illustrated. So also here, this idea that from nature to data banks, the kind of classification schema that we used to in biology and in classifying plants, etc., and those those different species and families, that suddenly we can see a similar kind of schema being applied to a lot of the data that is being produced and subsequently scraped and then used to train these models, and how suddenly all of these different categories, different aspects of our lives become training data. And also this other project, both of those collaborations with the same person, Vlad and Jola. Here it's the project by Vlad and Jola and Matteo Paschinelli, this idea of the null scope. And again, we can see how they visualize this idea of where training data comes in and how those different taxonomies have these effects downstream or upstream, depending on how you look at it. The practices of selection, labeling, etc. These taxonomies then are embedded into at least part of the process of developing a model that later on could be used and operationalized in some real world context. Okay, I also gave you this article to read, which again I think was quite self-explanatory, but looking at the genealogy of machine learning datasets, specifically ImageNet again. And it also, whilst pointing out some of the similar problems that also in the Kate Crawford piece was very kind of clearly explained, they also just really
Magdalena,
highlight.
do you think we could have a small break? I mean, maybe after you finish this, or like
Of
5, 10
course,
minutes?
sure. I will just finish this slide and then we can have a break. Yeah.
Great, super.
Fantastic. Thank you for this. Yeah, sorry, it's very good to tell me. Okay, so yeah, this final point that they highlight just this kind of imperative of data accumulation in the field that quote, the drive to collect more data can be motivated by several distinct but connected factors. The ideological formation of data holds that one can and will obtain better predictive accuracy with more data. So again, there's a lot of kind of faith in that fact that, you know, with more data, you know, theory is obsolete and, you know, and you can have all the insight about the world from just collection of data, and you can also have successful predictions. So with this kind of ideology in mind, even though we can show how these classifications underpinning a lot of these data and data processes, data collection processes, there is still this belief that, okay, well, data, there can be more data, better data, etc. That there's still this kind of ideological commitment to data accumulation in the field. And that also is something to keep in mind. Also, I guess for me, why I put this classification logic as the first week, because I also personally, I think it's a very useful tool for looking at both predictive and generative AI to like dig into the data set and see how it was formulated, you know, how big is it, where it's sourced from, etc. I think it's a very useful critical tool, but I think also it has certain limits that, you know, data itself is not the only aspect of machine learning systems that is worthy of analysis and potentially, you know, critique, as we'll see in the following weeks. So yeah, that's why I put it as first, because I think it's quite self-explanatory and it's useful. But from next week, we'll also look at more closely at learning algorithms and models, etc. Okay, shall we have a quick break then?
So, what do you think? Like 5 minutes, 10 minutes? How long do you want it? How
Yeah.
people feel? Like, I don't know, 5, 10 minutes?
Do we have some feedback? I can't see any. Um,
5 minutes? Okay, cool.
Fantastic.
So, we'll back in 5 minutes.
Okay. See you shortly. Shall we get going? I don't know if people are
Yeah,
back.
I think maybe we have some response in the chat. Maybe people can respond. Like, are we back? Yeah. Super. So I think you can continue.
Great. Okay. So I will share my screen again, but please don't worry. The presentation is almost. I'm almost there. So just to wrap. Can you see the slides? Okay. Great. Thank you. Okay. So yes, of course, like I said, I think the readings were quite self-explanatory, but you know, if there's something that isn't clear, of course we can discuss it, but I'm mostly also, you know, excited to hear what you make of it, and also potentially, you know, where else it can be taken. Is it useful also for something else that perhaps you're interested in, and how you approach the problem of machine learning. But I have in some other kind of examples and concepts that also where we can see how we can use some of that theory about classification, this way of thinking about data sets and classifications that underpin the data sets. So this is just an image of the IBM's diversity in faces dataset that was mentioned in the text as well. So as you can see very clearly the kind of analogies that Kay Crawford makes with, craniometry, and, the science of trying to prove racial inferiorities and superiorities, and this idea that we can measure people's facial features in order to infer some other qualities, and seeing this data set, which is ostensibly positioned as a way to be more diverse, like a nicer data set that will not be harmful for people, as of course these connections to these very problematic pseudoscientific practices of the past are very clear here. And I have an example, again, I don't know, perhaps I won't go through the whole thing so that we can have more time for discussion, but I just wanted to show you an example of how it is a good practice, or an interesting practice, definitely for me, I hope for you as well, to look at publications in machine learning, but also in other disciplines that increasingly use these methods and use these technologies for their own purposes. And see how they're used. And whilst a lot of these papers do involve a lot of technical vocabulary and a lot of maths, etc., there is definitely value in still looking at how these projects are narrativized, how they are described, how the choices are justified. So even if you can't engage with the technical detail, there's a lot of very insightful information that you can still engage with, and those kinds of, as I call logics, but those frameworks, the analytical frameworks that we'll be discussing, including classification, but also the frameworks that we'll cover in the following weeks. We can already, having that in mind, we can engage critically with some of these papers. So this is just one that I wanted to very quickly show you, but again, you can engage with it later on as well. It was this quite, infamous, again, paper by Wang and Kaczynski published in social psychology, and using deep neural networks as a way of detecting sexual orientation from facial images. So of course, I think for most of us here, quite obviously a problematic project, but it is quite revealing to see how the researchers talk about these ideas and how they structure this method, and what preconceptions they already bring. So we can already see that, they kind of take it for granted that faces contain much more information about sexual orientation that can be perceived or interpreted by a human brain. And they adopt these methods that are very widely used in machine learning and predictive AI, especially, in order to kind of demonstrate it. So just looking at how some of these, even as a research problem, how it's justified, and how it's drawing on some scholarship that claims that you could infer some characteristics, like parts of human character from facial appearance. So already it is trying to show the kind of optics of science, and having some kind of rational agenda. So interrogating, looking specifically at how these claims are positioned and how they are, justified, is always actually a very useful task. And even without engaging with the technical detail, there's a lot that we can engage just by interrogating these claims and logics. And here specifically, just looking at how they construct their methods. and showing that they obtained facial images from public profiles on a dating website, and how they use face detection software, which here you have an illustration. So again, this idea of like measuring faces is very problematic practice, and how then employed crowd workers in order to verify that the faces were adult, then also checking, for the kind of visible characteristics, or, the kind of characteristics that we are used to sometimes problematically classifying as humans. So, race, gender, etc. So just using this crowd working platform in order to classify people in this way, in order to verify the faces, to kind of verify the labels and data. And then also extracting facial features using, again, another ready product and then ready model, and then like also interrogating how many layers of off-the-shelf models are involved in constructing a problematic study like that, and being able to break it down and see, okay, well, how was this tool developed? It's always a kind of worthy practice, I think, to really engage with these papers and not be put off by some of the jargon of the ML speak and some of these terms, but actually breaking it down is not as inaccessible as it might seem. And also in terms of classification, and they had different ways of showing that, okay, you can infer things like sexual orientation from somebody's face. And by looking into how some of these methods were set up, we can then very clearly find also these logics of classification that also help us to show how these methods are inherently flawed on their own terms, like not even just as like an obviously problematic practice, but on their own terms, there are flawed methods. So here they say that the study shows the accuracy of this classifier is not limited to facial images collected on a dating website, but could correctly classify facial images recorded in a different environment on Facebook. And interestingly, how they identify these, the users on Facebook as gay males, it was by people following certain pages that have certain names, like Gay Times Magazine, I Love Being Gay. So this massive leap that is being performed here in terms of this very, like data point that somebody follows a group on Facebook to this judgment about a person. So seeing how exactly digging through some of these methods is almost spelled out, and being attentive to how it's constructed allows us to very clearly point out the flaws with these systems. And also in the general discussion, how they talk about what the study finds. It makes these claims that it helps boost our understanding of the origins and nature, broad range of psychological traits, of course, deeply problematic, but also how they describe the limitation of a study is also very telling, that they're saying that it might be possible that individuals with more discernibly gay faces are more likely to come out. So again, even when the studies, most of the studies, especially using ML methods, are quite used now to pointing out the limitation of a study, but also what is considered a limitation and how it's argued. It's also quite insightful into some of the values and problematic classification systems underpinning these projects. And also at the very end, in the conclusion, this project is framed as potentially showing that this is a problem, that it is, according to them, possible to infer such characteristics just from somebody's face, and that it is important for them to have the study as a kind of safety precaution to kind of raise the awareness that it can be done. So maybe we need more privacy. So also like how the studies, the motivation behind the study, how they are trying to justify why it's important to do this work. It's also very telling when we're trying to show how on their own terms these projects are deeply flawed. Okay, and just final point, just to wrap up, one more point on benchmark data sets. So this is from that paper that I uploaded as a kind of reference material, where researchers show the different iterations of the ImageNet data set, and how, from the announcement of the project until now, there are still different iterations. So even though the problematic category of a person is no longer there, there are many categories and many, parts of that data sets that disappeared over time. The data set is still very much used, and it is, it's still it still matters, and it still is part of a lot of the work done in the field. So that's why it's important to still talk about it, and that's also why it's important to pay attention to benchmark data sets in general. People also show the different dynamics between benchmark data sets and how not only they are used to track the quote-unquote progress in the field and how the new models are doing, but also we can track the kind of community dynamics and seeing at what point which model and which techniques achieve the kind of best result, the kind of state of the art, and then seeing who was involved. And we can also see how there is a certain clustering of all of the resources around the industry, not just academia, like mostly industry or partnerships. So we can also see how a lot of these big tech firms are still investing a lot of money in testing their new models on some of these popular benchmark data sets. So again, paying attention to how they're used, how they're constructed, who is involved in trying to get a better result is also very telling when we're trying to find out how the field operates and what values underpin a lot of the research, what priorities underpin a lot of the research. And final point on benchmark data sets, which also here applies also specifically to ImageNet, that some of those very canonical benchmark data sets, they become conceptualized as a kind of a general, as being representative of some kind of general capability. They're very often, they even position like that by the publications that announce the construction and release of a data set. And so here in this paper, they talk about ImageNet, but also GLUE, especially for NLP methods. And the researchers point out that these datasets are often, quote, elevated to become definitions of the essential common task to validate the performance of any given model. So sometimes they stop being just a data set that's used to train, machine vision to develop a model. They become almost the definition of a task. And that's also why then, keeping in mind all these problems of classification and being able to look at these data sets and seeing, okay, they are so incredibly meaningful, they become the definition of a particular task in the field. Okay, what is happening in this data set? What kind of preconceptions and assumptions underpin the data set, and how that might then result in certain effects of these technologies when they're operationalized in the world. And that, like I said, that also applies to generative AI. And the problem of benchmarks in Gen AI is, of course, like a whole other huge issue that is being discussed. But yeah, this just to highlight that this problem is very pressing across all aspects of AI. So just to highlight, that this goes beyond ImageNet and beyond predictive AI, and certain data sets have these lasting effects in the field. Okay, I got to the end of this presentation. So yeah, I would love to hear your thoughts, especially on your thoughts on this topic of classification and this unbenchmarked data sets and what you've read for today. But also if you have other questions as well that you want to answer now, even if they're technical, then of course we can do that as well. And I'll stop sharing and over to you. I don't know how it usually works, Jorge. Do people just unmute themselves and start talking, or?
Yeah, I think like just
Okay.
Yes, hi. Thank you for this.
Hi.
I'm going to ask several stupid questions because I'm still kind of feeling my way into this. I'm a visual artist, so it's all, new to me. And so one of the things that was really fascinating, you mentioned the mechanical Turk. I've never heard about this. So I'm wondering, so from what I gather, it's actual people who are doing this work, even though it's called mechanical Turk. Where did they get anyway, name, first of all, that's already shocking. And what you're saying is that basically it's a huge data set labeled by people that then they're comparing AI systems that are doing it mechanically, whether they correlate. Is that correct? Am I getting that right?
Great question. Thank you. It's another one of those topics which it's very difficult for me these days to gauge, like how obvious it is to everyone or whether it's not. So thank you for asking that, because it's a great question. So yeah, Amazon Mechanical Turk it's a crowd working platform. So it's actual people who connect to the platform, and they perform these very small tasks. So it's usually a data labeling, filling out surveys. They have to do it very quickly because obviously they paid very little. Well, the term comes from this concept, which I can also upload some reading because Kate Crawford also talks about it. But yeah, this idea of having this setup where for I think it was for playing chess, and this idea that the people thinking they're playing with a machine, but actually being operated by a human being. And some people call a lot of the crowd working platforms and the crucial work that these crowd workers do for the development of AI. Sometimes it's called artificial intelligence, because a lot of the stuff we think things are automated and done by AI, but in fact, some of those tasks are performed by humans. So for instance, also things like I don't know, if you call an Uber driver, or you make an account on Uber and you upload your document in order to verify that it's you, and there's this idea that it would be an algorithm that scans it and confirms that you're a human, but actually very often these tasks are also performed by crowd workers. So there's this idea of AI that's actually underpinned by human labor. And in terms of your data labeling, it's very much that very often people, like in the context of ImageNet, there was this taxonomy of words and categories. So people just had to assign images to the taxonomy that was there already, but different data sets are labeled in different ways. But yeah, that is the nature of the task.
Right. So whatever prejudices or preconceptions the workers may have, or like how some assumptions are made already is already in the data set in a way.
Absolutely. Absolutely. And it's also, again, there's something I really want to focus on predictive AI, because then I think it's more self-contained, but also just to highlight that, with a lot of the image, because here we're talking about labeling images. So we're talking about machine vision, we're talking about object recognition. Of course, there are, not all machine learning data is visual. But especially now with Gen AI, where a lot of it is visual and a lot of it is also like premised on generating images, then some of the data sets we don't know what the training data is because it's proprietary. But for instance, Stability AI uses this curated data set Lion 5B. And there is a great research project that looked into it, how it was labeled. And because it was no longer labeled by humans, the huge scraped data set, a lot of the labels that were being used were from the kind of alternative text that very often is like an accessibility thing that you annotate what the image represents, or tags, etc. So it was also scraped from places that already had some kind of caption involved. So even if humans are not directly employed to do it, there's already a lot of preconception that can go into it, and also clearly a lot of noise. That there is very often there isn't even this intentionality in somebody assigning the category by it being related to something that might be a lot more accidental.
Hello. Can you hear me okay?
Yeah, hi.
Hi. Thanks for the lecture. That was really good. That was really great. I actually, and I know again we're talking more about the predictive models, but I do train LLMs for my job. Started as a part-time thing, and now it's about to become my whole thing because I'm getting paid way more money than I've ever made in my life to just, write and critique their writing. And I have found it really interesting how when you're trying to determine, I have to do a lot of projects where you try to bait the models into saying something dangerous or ethically disgusting or any number of different things. And it's interesting how much the programmer's ideas of what is or is not ethical is a huge stricture for that. And like was what was brought up with the image training, sometimes I have to go and edit one of their responses and basically completely rewrite it. And then that becomes, it gets whatever you would call it, it gets a strong reward for that message because it's supposed to be a perfect message because a competent human wrote it. But there's obviously all of these little ways. Like I think about how many hours I'd have to do before there's some little element of like the particular way that I write in this thing. And there's people reviewing your work and people reviewing the people who are reviewing your work, but there isn't really anyone saying like, at this like granular level, I don't know, the little choices they could be making. Yeah, so I don't know. It's all very interesting to me. I know actually a very small amount about how a lot of the technological aspect of it really works still, because all I do is talk to them. But yeah.
Super interesting. No, I mean, yeah, I'm trying to keep into predictive AI simply because some of the, philosophical kind of frameworks we're going to look at, they will not apply as neatly or won't be like as instantly useful for talking about these systems when we talk about Gen AI. So they work really well for predictive AI, but in terms of the kind of the process you describe, it's not too dissimilar. Like, of course, there's the pipeline in a sense, and predictive AI is a bit more streamlined. It's a lot more streamlined actually. And even though it's still, for machine learning and deep learning, you can't know exactly what's going on, we can have a good sense at least of the process, right? Whereas with a lot of the Gen AI and with foundation models in general, like you have the foundation model and then they are adjusted to some other downstream users. So it is a lot more difficult to track exactly the effects of certain choices and certain parameters and the fine tuning. But this process, of the kind of reinforcement learning from human feedback, I think, it's you say you don't know exactly how it works. I don't know if anyone knows exactly how it works. It is, I think, more of a trial and error exercise of the sort. But it's also quite interesting for me from this perspective of, where's that human judgment or the human labeling? Because, in AI, there's this anecdote, parable or something that people say is, AI is kind of like making a stone soup that, you can make, like you can put stones and then have some water and then you say it's a stone soup and you taste it, it's like, well, maybe it's okay, but maybe it would be better if we like add some vegetables and then you add, and it's like, well, it's okay, but once, I use these spices and so when they made it better. And it's like all these people who come and contribute these different ingredients, and at the end, people trying to like, oh, this is a really good stone soup, even though, it has nothing to do with how it was originally built. But all of these like, fine-tuning contributions then suddenly amount to something that, is clearly, people respond to very well, and it's clearly an incredible technology. But yeah, being able to track exactly at which point that, specific influence or, the kind of reinforcement learning process had a particular effect, I think, yeah, that is quite, enigmatic, I think, for everyone at the moment. So
Yeah, I mean, with the point about nobody knowing how aspects of it work, I've worked at this with this place for a little over a year now, and I've seen a lot of things develop in the ways they try to access certain issues. Like there were several months where we exclusively across all these different platforms had to punish them for saying like a cheery little like peppy response at the very beginning before getting into their like, sure, what an interesting question, like things like that. We had to punish them for that just across the board everywhere. But they still do it. And I've seen the admin people say like, we don't know why it's doing that. We don't know how to make it stop. Just try to, you usually get two responses and then you weigh which one's better. And a lot of the time they'll both just have the same issue, which I guess is where the sort of editing thing comes in. Um, yeah, I don't know. Another thing that drove me crazy was I was getting way more money than usual because I passed a like philosophy quiz that they just put in my dashboard thing. And I was having you had to come up with a philosophy problem that had an unambiguous right or wrong answer, which in the first place is like almost usually doesn't make any sense. Um, and then you had to lay out the steps of reasoning that you had to do and um, evaluate what level of expertise would be necessary to answer the question. And none of this made any sense. It was total nonsense. And there were lots of other philosophy people who were in the sort of chat for this project saying like, this doesn't make any sense. Like you just took this, this was clearly like a math project, and then you just tried to apply it to a different discipline where it just doesn't work at all. I thought that was really silly, and that kind of stuck with me, that there has to be an unambiguous right or wrong answer. It's almost impossible to come up with like a philosophy word problem or something that would work like that.
yeah, that's fascinating. So is I don't know to what extent it's you sign some NDAs, but am I sensing that it's like a reasoning model? It is supposed to be tailored for this kind of like talking to itself and explaining its reasoning? Is that kind of the idea, or is it just part of the training for the fun of it?
Yeah, I don't think there's some things that I have done with them that are technically confidential, but I think it is just supposed to be able to um reason, make it look like it's reasoning, and yeah, explain all of the steps of its reasoning, which it's also, even if it gets the answer to like a logic puzzle or something, right? It's very bad at laying out like succinct steps, because I mean it's not really reasoning.
Yeah, no, thanks for that. It's fascinating. I'm looking forward to also chatting more about it. But I think there is a hand up by Peggy Bloomer.
So, in generative AI, there's that hallucination that happens occasionally. Does this also happen in predictive machine learning?
So in the kind of sense of hallucination as we define it, then not so much, because we usually, this term now denotes the quality of the output, right? So that's why it's in generative AI, because generative AI generates an output, and then if we're looking for something that is factual or corresponds to something we expect and is completely not there, and we're saying, okay, they hallucinated it. Of course, that we could draw some parallels, this idea that models do not represent directly the data. They do not represent also the kind of target, phenomenon of the model, whatever is modeled. So in this way of the kind of idealization and, slightly like false models or, false representation and distortion, in this way, that's definitely the problem, across AI, because that's also something that hopefully will be directly relevant to our discussion about models, because that's what comes with, if we're trying to have a generalized pattern that stems from some kind of data, not everything will be included. We can't include everything. But the term itself, as far as I understand, it makes a lot of sense in generative AI. It wouldn't work the same way in predictive AI, to my mind. Thanks for the question. Did that answer your question, or is there some?
Yes, I mean, I have many, many, many concerns about this, but I'm sure that's going to unfold. Especially the things that were on the bottom of the chart seem to be the things that would keep us more safe and have a democracy and more voice as humans, and that's been minimized to hardly being relevant. So, but I'm sure we're going to talk about that someplace when we get there.
Fantastic. Okay, great. I'm also very happy to hear that you're interested in this, and that people are still interested in the kind of sociopolitical aspects of AI and the consequences of these systems, because I feel also these days that everyone's so interested in generative AI and the kind of like what images you get and what discussions you have with LLMs, which is great and it's fascinating, and it's a philosophical material on its own. But yeah, I'm very much interested in the kind of sociopolitical consequences, and that's also what this seminar is designed around. So I'm very glad to hear that people are interested in these issues related to AI. Any other questions? Or also, yeah, please let me know if something was unclear, because I was trying to pitch it at this sort of introductory level, but like I said, it's very difficult these days to know what people already know, what they don't know, and where they're coming from. So please feel free to ask any
I do have one question. If trying to like couple the last two questions. So then the difference, if I understand, between generative AI and predictive AI, especially in that case that Peggy was asking about this idea of hallucination, is it that predictive AI will be more like low level, as in the kind of like yes/no classification, while in the generative AI is more, could be like a, if you have a conversation with ChatGPT, it could respond something that is complex. That of course, if you put it at the again, like in a low level, will be in a matrix or to yes or no, but in the for the user, it's something that can interact more directly.
Great question. So yeah, let's clarify these terms. So first of all, the distinction between predictive and generative, it's not like it's not, like a definitive distinction. It's not also like a neat distinction, because of course, prediction also underpins generative AI. So it is the kind of distinction that is just generally used in machine learning, and it's also particularly relevant in relation to questions around risks and harms and legislation around them. So the main distinction, the kind of main difference between the two, and also that we could distinguish other forms of AI as well. I don't know, we could think about self-driving cars as a type of AI that, again, doesn't fit neatly in either of those categories. So the two categories are used mostly to distinguish the foundation models, LLMs, diffusion models, all of the stuff that generates an output. So the stuff that kind of be, from the last few years, basically all of these big models. So why we use them is because they generate an output, whether it's a text, an image, something. Predictive AI is used as like a diagnostic tool, a decision-making tool. It's something that produces, the output of it is usually a numerical value. So it could be a classification, a kind of category of one or the other. It could be, some kind of like clustering of data, like the dividing into different clusters. Could be calculating a probability. It usually will be a numerical output, and it usually, doesn't have this direct, output that we engage with visually or orally, that it doesn't have this kind of, what we associate with the kind of creative output of Gen AI. So yeah, it's a very broad distinction. It's not very scientific, but it's mostly to distinguish between different uses, the different kind of systems, what they're useful, where they used, and then, there are obviously differences in how they trained and constructed. But the main distinction is what they're used for.
Sorry, Peggy. But if I understand, so tell me if I'm wrong, then is that you will say like then the predictive AI is more abstract in that sense, while the generative AI will be more and also abstract, but also what you call high stakes, no? Like it's more something for in a policy level or something that can become abstract for other people to use in high stakes. While generative AI, it generates something that can be an image, but it's not the same. It has a different level of impact, right?
So it depends. It depends on the context. So I'm not sure about this question of abstraction, because when we talk, predictive AI, there's still very clearly like specific products. The methods, the methods, we will talk more about the methods that underpin them, and they kind of general, pipelines. But usually how, they exist, how they operationalize is specific products and tools that usually companies sell, to governmental bodies, etc. There'll be products like, like a system that assesses risk, a system that, classifies new customers into groups that they can be targeted with certain advertising. So the question of high stakes is like a separate question. So that's kind of how I'm trying to narrow down what we will focus on specifically. So predictive AI doesn't have to be high stakes, because we can use prediction to, like I say, classify emails, right? We can say this is high priority, low priority. And whilst it could have high stakes, on the face of it, it doesn't have to. And it's the same with, I don't know, recommendation algorithms. We can make an argument for that being important and have downstream effects, but on the face of it, potentially no harm. So predictive AI can be used in all sorts of stakes kind of contexts. And then the high stakes are those specific contexts where, the stakes are very high and people get harmed. So policing, any, kind of welfare systems where people, get penalized, social services, pre-trial risk assessment, kind of automating also decision-making in courts, border control, all those kinds of things that, we can make a very good case for. Even when they're not automated, they're very punitive and very problematic. But then, when they are, especially when they receive this additional kind of layer of obfuscation, when they're used, when they're automated to this extent, then, there's this additional problematic layer, and they are very clearly high stakes contexts. It's those contexts where people get harmed. There's a direct effect that is potentially very severe to public health as well, etc. Did that answer your question? Was there another aspect of it?
Yeah, thanks. Peggy's help.
Well, I sort of was going to ask something more about that. So do we get tricked in the fact that we're getting some sort of answer that seems like it's numerical and therefore has to be a quantity when we're doing something that's predictive, when as we're doing something that generates, we are using our humanist features to see that it's really out of the ordinary? I mean, I'm thinking yesterday I asked Siri to tell me how I could get to the nearest FedEx location, and told me that it was 116 miles away in Long Island. I live on the other side of the Sound. There is no way for me, except for swimming or getting on a boat, to go that 16 miles, which, I would have thought. So are these so siloed also that they can't connect with each other and do the logistics that really need to go together with the predictives? Because that was a serious problem. She just didn't realize the geography of the location that she gave me, you know.
Fair enough.
She was not perfect. She was only an artificial assistant. You know, I always yell at them.
Oh, great story. I mean, a great question. So, in order to know exactly what happened, I don't know exactly how Siri works. I don't know if at this point it is a kind of what they call AI agent. So it is designed to be this kind of assistant, and it definitely uses, you know, some form of AI. Potentially, if it is, then it potentially uses a few different models. If that's the case, yeah, I guess we would have to look more closely how these systems are constructed, and to what extent, because of course these kind of voice assistants, they, you know, they predate a lot of this incredibly, you know, effective AI that we have at the moment. So I don't know to what extent it is more rule-based, that it goes to a certain, you know, database when it recognizes a structure of a question and then, you know, brings up an answer. As far as I understand, you know, before it was a bit more rudimentary like that, you know, the information was very often not quite there because it was picking up on some very small word. I bet I don't use these systems, but I suspect that these days they're a lot more elaborate and they presumably use some form of AI. And, you know, a lot of these companies are trying to, you know, pitch themselves as producing these AI agents that are supposed to be like our personal assistants that can do everything. But yeah, in order to answer this question specifically as to what happens, we would have to look more closely at how the system operates. Is it AI? Is it, you know, what it uses, what databases it has access to, and how it functions. So unfortunately, at the moment, I can't. I don't know, but it would be definitely interesting to see what information about it is available and how Apple is presenting that product at the moment.
She changed her voice so she speaks differently now.
Oh, interesting. Okay, that could be.
My phone must have had an update to a new AI system.
Oh, okay.
Not one with geography, even though she knows where I go every single day.
Maybe she just didn't want you to go there. She was just like, it's not a good trip.
Okay,
Across
that's
the
great.
Long Island Sounds, clearly not.
We should close the session for now. Maybe one reminder for the students to please find yourself, like add yourself into the presentation list in the Google Sheet when you can. Thank you, Magdalena, for the great session, and thank you everyone. And I
Yeah,
guess
thanks everyone for your questions. And just to remind everyone, feel free to drop me an email whenever you like. If you have questions or comments, then yeah, feel free to ask. And yeah, thanks so much for coming.
thanks. Till the
Thank
next week.
you.
Bye.
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 Thank you.